Hey guys, this is the start of our new way of learning, so let's kind of figure this out together, okay? We're going to try several different things, so you need to let me know what works the best. So I know I've been able to hand you notes in the past to kind of fill out, but since we don't get to see each other, I can't do that anymore. So I am going to be making these hopefully pretty short videos to walk you through the lesson in the textbook, which is where we've actually been living. You just didn't quite know that. And then you will have a certain set of problems to work on that relate to that topic. I'm going to go ahead and break each section down into chunks, so you're not doing like all of 8.1 today. We're going to do the first part today, and then tomorrow you're going to be looking at like the word problems and the real life application stuff. So we're going to try and break it into smaller chunks for you. Since I know that school can be real tough to just sit down and kind of power through a bunch, I'm going to try my best to break your whole school math into about 30 minutes a day so that you can kind of space it out a little bit more and not have as much on your plate at one time. Okay, so here we're looking at 8.1. Okay, so this is kind of where we're starting, and we're starting this brand new chapter. So we're really looking at quadratics. And I'm not going to take full notes here. I'm just going to kind of highlight the important things that you can come back to and refer to later. If you want to take a little bit more detailed notes, that would probably be beneficial to you down the road when you're doing your homework. Okay, so let's talk about what a quadratic function is. A quadratic function has this specific format. Hopefully you should not be surprised by this. We've seen these before. We looked at this a lot in the last unit, but now we're putting a special name. One thing I want you to note is that this is kind of really key and important. That means that we're dealing with a quadratic, that exponent of 2. Okay. Another name for this kind of equation or this figure is a parabola, and you'll see that over here. Okay, so here are some characteristics that we're going to be looking at, and it's kind of a bummer because I can't draw on this book, but I can draw on my Word document, so I'm going to kind of go back and forth a little bit. Okay, so we'll see that this is kind of a curved shape. So we've dealt a lot with lines last semester, and this semester we are gonna spend the rest of our semester dealing with these quadratic functions. Okay, so the parent function, I want to work, that parent function just means I'm not doing anything to it. You see that that's the most basic piece of the quadratic function. So the parent is y equals x squared. Okay, I'm not doing anything else to this x squared. So let me just draw you a really quick picture that you should probably really also draw in your notes too. So I'm going to draw the parent function, which looks something kind of like this. And we want to keep those arrows because it does continue on in both directions. So then we have this point where it changes direction. Okay, that's called the vertex. The vertex is where it changes direction, and you'll see that the vertex can either be at the top or the bottom, and we'll talk about that again later. So just know that the vertex is where it changes direction. Okay, we also have an axis of symmetry. So the axis of symmetry is kind of purple. Let me try my yellow one, which was not any bigger. It's that line that goes through the vertex, and it will always go through the vertex, where if I fold my quadratic in half, it will look just like itself. Okay, so it's the place where I can fold it in half. Okay, so now let's look at this first example. Consider the graph of the quadratic function. Using the graph, you can identify characteristics such as the vertex, the axis of symmetry, and the behavior of the graph as shown. Okay, so here we see, and when we're looking at these functions, you'll see decreasing and increasing, and that's really important. The thing I really want you to remember, it's as I move from left to right. So kind of as I read my graph, is it going up or is it going down? Okay, so here you can see that I'm decreasing, right? Because as I read from left to right, I'm decreasing until I reach my vertex, which is the point where it changes, and then I start to increase. Okay, so you'll see here that that vertex is at -1, -2, and the axis of symmetry is a line, so it's always going to be x equals whatever that x value of the vertex is. So from this picture, I can also see that my domain is going to be all real numbers. So just a little hint here, for a quadratic function, your domain is always going to be all real numbers because it continues to the left forever and it continues to the right forever. So that's what gives us that all real numbers piece. Okay, so in this example, my range is all real numbers greater than or equal to -2. Because as I'm looking at my y values, remember that range is y, the lowest I can ever get in my function is this -2. Because if I'm down here, I'm not touching my graph at all, and I start touching it right at this -2 and above that. So that's going to be my range. Okay, so when x is less than -1, we have a decreasing function, and then it turns into an increasing function. So just some things we can see, especially from the graph. Okay, here we go. So now there's a little bit something different. So now I've put this a value in there, okay? So let's go ahead, and I'm gonna draw this again because this is actually really important kind of information, okay? So I'm going to use blue as my parent function, and I'm going to label this y equals x squared. So if I have an a value, so some number in front of that x squared, and that a value is a fraction or a decimal, it's going to look more like this. Okay, it's going to be shorter and fatter. So this is where 0 is less than a, which is less than 1. So a is some fraction or decimal. You'll see we're not talking negatives yet. Okay, but it's going to be shorter and fatter. Okay, so then if my a value is greater than 1, it's going to be taller and skinnier. So it's going to look a little bit something like this. So this is going to be a is greater than 1. You'll see here that I don't ever have an equal to 1 because that's what this one is right here. There's a 1 in front of that x squared that we just don't see. Okay, so now you see over here in our book that there's some that are opening downward. And that's really just if there's a negative in front. So I'm not even going to redraw everything. I'm just going to say if negative, it flips. It's also called a reflection, is the actual mathematical term. I would take a flip, right? Because it just takes it from that top and then it flips it down below the x-axis. Okay, so I just want you to remember that if that a value is bigger than 1, it's like I'm taking that quadratic or that graph or that function and I stretch it big and tall. It doesn't matter whether it opens up or down, but I'm stretching it. And if that a value is a fraction or decimal, I'm kind of putting my hands on it and I'm smushing it down together. So again, it doesn't matter whether it opens up or opens down, it's kind of smushed still. Okay, so we're going to be graphing some of these. And yes, you can use Desmos to help you graph them, okay? So we're being told to graph 2x squared and compare it to our parent function. So I see that this a value in front is greater than 1, so I know it's going to be a little bit taller and skinnier than my original function. So we can graph it using Desmos, and if you don't have Desmos, right, you can always kind of make a table. So we just pick random x values, generally do easy ones, and then come up with your y values, and then plot your ordered pairs. So you'll see this graph, the black one is my parent function, is that just x squared. The blue one is that new function, and you do see that it is stretched a little bit taller and skinnier. Okay. Okay, so let's look at example 3. So example 3 just tells me now I'm going to have a negative. Okay, so I'm being asked to graph this function. It's a -1/3 x squared. So compare it to my parent function. So first thing I notice is that this is a fraction, which means it's going to be smushed a little bit. It's going to be like short and fat. I also see that it's negative, so it's going to be not above, but it's going to open up down. Okay, so we came up with our list of points, or we used Desmos, and we see here's the parent function in black. Again, it's a little bit shorter and fatter, and it's reflected. Okay, so here's some of the math terms that I want you to start getting to. So since we're dealing with things that are up and down, that's vertical, right? That's up and down. So we can say we have a vertical stretch if that a value is greater than 1, or we can have a vertical shrink or compression. I personally use shrink, but it doesn't matter if that a value is between 0 and 1. So when I'm using those math words to explain what's different between this function and my parent function, I would say that this is a vertical, right, because it's up and down, shrink by a factor of 1/3, and a reflection in the x-axis because it's now opening down. Okay, So that's really the key important stuff that I want you to get from this first section, this first part of 8.1. We're really going to be looking at what does this mean in our next little section. But for now, just really get in the habit of, if it's positive, if that a value is positive, it opens up. If it's negative, it opens down. If it's greater than 1, it's going to be kind of tall and skinny. And if it's less than 1, it's going to be kind of short and fat. Okay, so now you have enough information to go through and do those specific problems that I've given you. Do not submit the assignment yet because you're going to be adding on to it tomorrow. If you accidentally submit it, just shoot me a quick email and I can hand it right back to you. So thanks, guys.